This is the third lecture for Chapter 5, and it'll be a rather short lecture. There's not much left in this chapter. So where we left off last time, we were looking at Hess's law and using enthalpies of formation, which is what we have in these three equations here. And notice again we have four substances listed up here at the top, but we don't have to worry about the heat of formation of oxygen because it exists. So if we take these together, and notice how we have some flipped around. I have a product sitting here on the left, and then I have another product, of course, on the right, and over here. Actually, this is the way it should be. Better to use this example in class, but we see it laid out just like it is in the equation. So we have to take some of Hess's laws parts and put them in place here. So we'll see how this kind of comes together. Probably the one that really is just out of place is just the propane, because it's on the wrong side. As far as this is the product, and then you have the reactant sitting there on the right. So here's the equation, kind of putting it together. And these values just come off of the chart. So, and they read just right across here. So we have 3 moles of carbon dioxide, and the value off the chart is negative 393.5. Plus the other product, which is water. We have 4, match up the 4s, and this value again comes off the chart. And when you add these together, make sure that you are using the brackets, so you have to be good with the calculator. And again, it's products minus reactants. So these two products are sitting here first, minus the sum of the reactants. So I have 1 propane, and this is the number that comes off the chart. It's a negative value. And then again, for water, you don't need to worry, oxygen, you don't need to worry about it. It's just 0. So paying attention to the values and, of course, the signs of these values is really, really important. And we get a result which we should expect, that it's an exothermic negative value for that process. And just here's some values just to make a comparison of food, some things that we eat or drink and the values of them. So some things, the real simple ones here, just to make the comparison. Why are fats, you typically want a diet which is fairly low in fat, just because the energy content of fats per gram is more than twice the value it is for carbohydrates and proteins. So you have to watch those values. It's a little more complicated than that when you start looking at fiber and such that is in food, cellulose product, whatever. But you can kind of see the comparison of some of these numbers. And then energy in fuels, another one to take a look at here. Very interesting when you look at some of the fuels that we use. Using firewood, the kilojoules per gram, it's quite low in comparison to coal. So why did we switch over to coal once upon a time? It's higher energy content, and even more so when you look at some of the fuels we put in our car. But interesting, we just started switching over recently to natural gas. So the energy content per gram is about the same, but it pollutes much, much less in regards to carbon dioxide that it puts out into the environment. So it's a better fuel source from that perspective. But of course, the really nice one, if we could somehow harness the energy and get this to work, is hydrogen. 3 times the energy content. And it's the difficult thing is just trying to get this to work. So we haven't found the technology that makes it efficient to do this process. And that is the end of the lecture. So there we go. Thank you.